Okay, I'm going to go over the difference between set builder notation and interval notation. So this is like after you solve. Let's say that you're solving an OR problem and you end up with like x is greater than 1 or x is less than, let's do 0. Okay, so this is an interval notation, just kind of this in and of itself, that's interval notation. So I'll put IN, interval notation. So for me, I really like to see the graph. So this is an open circle pointing to the left, open circle pointing to the right, where either or graph exists. So to do this let's do instead of set builder, let's do interval notation first. I guess that's hard because that's inequality. This is written as an inequality. I don't know what I said. I'm so sorry. Inequality. There we go. So this is how you write it as an inequality statement. Okay, now to write this in interval notation, you will say how what the lines look like. Hopefully you can see that this line is pointing to negative infinity. It comes to 0 and it stops. So you can't touch negative infinity, so you use a parenthesis, and you can't touch 0 because it's an open dot, so you use a parenthesis. So you're saying the first part of my graph goes from negative infinity, it comes to 0, but it doesn't touch 0. And you know what else I'm going to do just to try to make this a little extra here? Let's pretend this was equal to 1. So let's fill that dot in so you can see what that would look like. So let's say you pretended and it was actually equal to 1 as well. So you describe what this line is doing. You're saying this line starts at 1 and now it's going on forever to positive infinity. So because it touches 1, we use a bracket instead of a parenthesis, and then the comma says, all right, and we're going to go to positive infinity. So we're going to write that with our interval notation. We're going to say it's union, like together with, going to from positive 1 to infinity. Again, the bracket because it touches. All right, so that's inequality statement, interval notation, and then let's do a set builder. I'll just do I'll just write it, set builder. Maybe I'll just write it. All right, so set builder notation describes it. So it has a brace, it says what our variable is, and then we just kind of like say what our variable is or what we have. So you can say x is a real number, and that real number is allowed to be less than 1, less than 0, excuse me, or it is also allowed to be greater than or equal to running out of room. One. So it's just kind of like a long statement about what we have. All right, so set builder notation describes what we have and almost writes it more or less like in a sentence. All right, let's do one that would be like an and problem. All right, so we graph it, we solve it, and let's say that we end with a closed dot here and an open dot here. That's what our final thing would look like, and that's probably because you graphed it down here and you saw where the overlap was, okay? So let's write this one as an inequality. So this is an and problem. So you would say the inequality is, it goes from -2, which has to be smaller than or equal to x, which has to be smaller than 1, but not equal to. So that's how you write it as an inequality. That's your and problem. Now let's do that as interval notation. So in interval notation, you describe what this graph is doing. So you're saying, well, it's not doing anything forever. So this time it's starting at -2 and it's going to 1. It touches -2, it doesn't touch -1, and we put a comma there. So we say, this time my graph, it starts at -2, it comes up to +1, and it stops, but it doesn't touch +1. In set builder notation, you're going to say, let me get my brace on here, your variable is x, and you're going to say, okay, x is a real number. So just kind of describe what you have. X is a real number. It has to be greater than, I'm going to abbreviate here, it has to be greater than or equal to -2, and it also has to be less than 1. So you kind of describe it. It's almost like you're saying this in words. Let's do a singular line, okay? So let's do open and pointing to the right, okay? So as an inequality, you would have solved that and you would have got greater than -1. That's an inequality. Sorry, the spelling. That's as an inequality. In interval notation, you would kind of describe what your line's doing from the left to the right. So you're saying my line starts at -1, but it doesn't touch. And then it goes on forever to positive infinity. So we're going to say starting at -1, going to positive infinity. But because you can't touch -1, it's open. You can't touch positive infinity because you just can't touch positive infinity. Like you can never reach the end. In set builder notation, you would say my variable is x, and x is just greater than. And you're more than welcome to say that with a whole sentence, or really even just saying it like that is perfectly fine. I guess we can do the empty set. So let's see. Let's say this is an and problem, and you happen to graph it, and it looks like this, and pretend you're supposed to be looking like it's an and problem. So your answer, the graph, is just the empty graph, okay? So as an let me change back to the pen. As an inequality, you would write, there's no solution. All right, you can't look, it's just none. You could, for interval notation, well, there's no solution, so you can just put the empty set. That would be perfectly fine with me. You could, yeah, that'd be fine. You could do, no, not even that. Nope, that's just it, just like that. And then for set builder notation, you're just going to give me the empty set either like that, or you can just give me the empty set like this. Okay? I hope that was helpful for you. The only one I didn't do is all real numbers. Like let's say that the answer is all real numbers. So let's say you get x is all real numbers. In interval notation, that's going to be -infinity to positive infinity. And in set builder notation, you would have x, and you would just tell me x is all real numbers. And you're more than welcome to use that abbreviation for all real numbers. All right, I hope that was helpful. Remember, the big thing with set builder notation is that it just kind of like describes what you have. So one more time for set builder notation, because I feel like that can be a very hard one. Okay, so let's say that I give you a list of numbers. I'm just going to pick something easy, okay? So what I'm hoping you see here, this is in roster form. All right, so this one's in roster. So what would that look like, therefore, in set builder notation? All right, so set builder notation, you can pick whatever variable you write. Let's say that this is like, I have it as a name A. You can be like, okay, little a. A is, you can use a lot of things. You can say A is a positive real number, or you can even say a positive multiple of 5, just describing those numbers. You could also say, if you didn't like that, you could say A is a natural number, because that's true too. A natural number. Also a multiple of 5. But what you wouldn't want to just say is that it's a multiple of 5, because multiples of 5, we could do like -5, -10, -15. So you either have to like really indicate somehow that it's positive. You could even, instead of using natural, you could use whole number. You couldn't do integer, because integer includes negatives. So set builder just really very in detail tells you the description of what you have as a list. All right, I hope that was helpful for you. Let me know.